Hello everyone, welcome back again to 40 Days of JavaScript. Today we are going to get started with the day 7. Day 7 is going to be filled with projects. We are going to do two projects together, and at the end of it, I am going to give you an assignment that is also another project that you need to submit. I'm sure you're excited about it. But one thing, if you are someone who has completed from day 01 to day 06 and then coming to this video, please comment and let me know that you have done it because we want to celebrate together. It's the last video of the first milestone and the first module. And congratulations for achieving this particular milestone and module. In the next module from next week, we are going to get into little more advanced topic of JavaScript. But before that, whatever we have learned so far from day 01 to day 06, let's apply them in building a couple of projects and learn from them. Don't miss the task again, guys. And if you enjoy this video, please post a like. Share this video with your friends and the coding buddies. That will be a great help. And if you have not subscribed, please do that. Let's get started with our first project. So the first project that we're going to do is a game. And this is a game that most of you are already familiar with. It's called Rock, Paper, and Scissors. You would have played in your childhood or you already know. Let us first understand what exactly this game about in case you are not aware and what are the rules of it so that we can start building the logic of this game. And while building the logic, we'll apply most of the things that we have learned in the previous sessions. So the rock, paper, scissors game goes like this. The game will be played between the computer and human. So you have to design something where computer will also take part in this particular game. Once human will select rock, paper, or scissors. So that means that human has to select either rock, paper, or scissor as an option. And in the next turn, the computer will select rock, paper, or scissors. And again, this turn will go on until we find a winner or a loser. Now, how do we find a winner or a loser? The winner will be selected based on these rules. If one is selecting rock and another is selecting scissor, rock can break scissor, right? Because if you have a scissor and if a rock, you can break it. So rock wins. If user is selecting paper, computer is selecting rock, you can wrap a rock, a stone using a paper. So it means paper wins. Whether user or the computer who selected paper, in that case, that particular entity wins. Now, if computer selected scissor and human selected paper, now a paper can be cut with scissor, right? So that means scissor wins. So whoever selected scissor, that particular entity wins. Here, one thing to remember that the computer selection will be very random. We won't know what computer is selecting until we see what computer has selected. So we will use some amount of randomness, and I'm going to explain to you how this randomness will be done. And then user will provide an input of the selection that he or she will be making, whether it's a rock or scissor or paper. Based on that, our logic will work. And at the end of the logic, we will announce who is the winner. That's a very simple game. So let us start thinking about this particular project. Now, what I want you to learn here, not first about the coding, rather, how can you think about breaking things into logic or in the logical sequence once you get a problem like this? This problem might be very simple to many of you, but the way that you go about project building is an art. You cannot just start sitting with it and start coding. You have to put some thought process behind it before you start coding. So for example, if this is my use case that I have to solve, there are a few things that I have to note down. Let's start noting down our assumptions. So this is called assumption before you start putting any code. So what are the assumptions that we can have for this particular project? One assumption is we have to prompt the user to get their inputs, right? That is one assumption. Then second assumption is the computer's selection will be random. That is the second assumption, because what computer will select, we don't know. It will be random. Then third assumption, we have to compare user and computer's choice, correct? If one is selecting paper, another selecting rock, we have to compare their choice and then match it with this particular rule to determine who is the winner. And then we need to announce the winner. Another optional step can be after the winner announcement, we may want to ask the user to play again or quit from the game. Fair enough. So these are our assumptions that what we are going to build, and then using these assumptions we are going to start coding. Now why do we call it assumption or not the steps? Because we are assuming before even start coding that this is what the things are going to be. It might happen that while coding we change these assumptions a little bit. It can happen, it may not happen, but let's take this as assumptions and get started. As we are building rock, paper, scissors as a functionality, so definitely we will keep all our code inside a function. We learned about function from the last video. So we will create a function, and the name of the function we can give as rock, paper, scissors game, and then the curly braces. Now, this is how we know that we define the function. But this function is not going to do anything until unless we call this function. So to start this game, we have to call this function called rock, paper, scissors game. Now to test that everything is getting executed correctly, let's do a console.log getting started with the rock, paper, and scissor game. Correct? Now this particular JavaScript file I have created inside a folder called RPS. RPS means rock, paper, scissors. And inside this particular folder where the JavaScript file is there, I have a HTML file. And this HTML file is loading this rps.js script. You can see over here, we know all these things from the day one. This particular HTML doesn't have anything other than saying this is a rock, paper, scissors project. And finally, this HTML, which is inside this RPS, is linked from a main index.html file using an anchor tag. This is pure HTML anchor tag, which has an href attribute. In that attribute, you can give the page that you want to link to this particular anchor tag. And here we have provided the link text. So if I run index.html file, I'll be able to see a link that says rock, paper, scissors. And if I click on it, it will go inside the RPS folders, rps.html file, which is this one. And this is going to load this rps.js file, which is this one. Here I have kept a function, and calling this function, the function is only having a console.log. So let's get started with our UI. If I go to UI and then click on this guy, I am able to see that it's saying getting started with rock, paper, and scissor game. Great. So that means my script is working, everything is stitched correctly. Now let me go ahead and looking into my assumption, start building the logic for this game. Our first assumption was that we have to prompt the user to get their inputs. That means we have to ask users some way that they can tell their choice whether they have selected rock, paper, or scissors. Now, JavaScript provides a few global level methods to interact with user and the application. One probably you know very famous one is called alert, window.alert, through which you can give an alert message. The another one is called window.prompt, through which you can actually collect the input from the user. And this window.alert, window.prompt are the global window objects method, which is available on browser, only on browser environment. Okay. And we can use them freely as long as our application is running on the browser. So to take a prompt from the user, let us first create a prompt. And then whatever user is entering, let us take that value and assign it in a variable. So let's create this variable called const user choice prompt equals to, the method is prompt. You don't have to take it from anywhere, you don't have to import it from anywhere, because it is available with the browser for free. And here you can give a text saying for what you are asking this particular input for. So you say enter rock, paper, or scissors. One of the option, please go ahead and enter. That's what you're saying. This will open up a prompt. If I go ahead and see the UI in this state, you see over here you are seeing a prompt, right? So this is the prompt that I was talking about. Now in this prompt, whatever you enter and say okay, that will come as a value, and that value will be assigned to this particular variable. Take let another variable called user choice. We got the prompt. From this prompt we will get the user choice, and this user choice, what we are going to do is like whatever user is going to enter, we are going to make it in a lowercase, or we can make it as an uppercase. Why? Because Let's say your computer is selecting rock, ROCK rock, and ROCK rock, everything is in the small case. Now user enter rock, but they have given rock in this particular case where R is in the capital case. Now if you equate, go to our session of the equality operator. If you equate capital ROCK and small ROCK, those are not equal. Those are two different strings. So those are always going to be false even though they sound similar. So for that reason, whatever user is entering, we want to make that in the lowercase so that we can always compare the lowercase version of user's entry with the lowercase version of rock, paper, or scissors. That's the thing. So that's the reason we are going to make this as two lowercase a method from string. Okay, we learned this method elaboratively when you go to the string session later, but for now you know this. Then after this, I need one more variable to hold computer's choice. So let's create another variable called computer choice. Now how this computer choice will come to me? This is where I want to teach you something called random number generation. Let's say I have to generate random number between 1 and 3. What does it mean? Between 1 and 3, I have to randomly generate a number. Now for that, great part is JavaScript provides a method called math.random. If you do this, JavaScript will give you a random number. But the problem with this random number is always in this decimal. It will be always like 0 point something. But we have to find a random number between 1 and 3. Correct, na? Now, if I get a decimal value, the first thing that you want to do with this decimal value is you have to scale this value corresponds to the range that you are looking for. To do that, the first thing that you will be doing, you will take this random value and multiply this random value with the higher threshold of your random number generator. So what is the higher threshold over here? The lower threshold is 1 and the higher threshold is 3. So first thing you're going to do, you are going to take this guy and multiply this one with 3. Now you get a number. Now once you get this number also is quite big, right? 1.2 something like this. Now this particular number you have to bring it to from this point decimal number to a rounded number. For that purpose, what are you going to do? You are going to call another math method called math.floor and you will pass this particular number. Now this is going to give you a rounded number which is like 1. In this case, it could be 1, 2, 3, whatever it is. And after that, the last thing that you have to do is you are looking for a value between 1 and 3, right? So sometime this random number, if you multiply by 3, the maximum that it is going to provide is of 2's range. So if you get 2 point something and do math.floor of 2 point something, you will get maximum of 2. But you are looking for a range between 1 to 3. It is going to start from 0 to any number. So you want to hit the number 3 also because your range is from 1 to 3. So for that purpose, whatever the result that you get, you should always add another extra 1 to it. And this is what is your final random number between 1 to 3 from math.random. Okay, so this is how the computation goes. So it means that if you want to find a random number, so what you will do, if I want to write as a mathematical expression this time, you will take math.random. After getting math.random, you will multiply that with the higher threshold. In our case, it is 3. And then you are going to put this entire thing inside something called math.floor value. After getting the math.floor, you are going to add one additional 1. So this is going to give you a random number between 1 to 3. If you want a random number between 1 to 10, you will just change this to 10. 100, you will change this to 100. So let's generate random number between 1 to 3 multiple times. First time it generated 2. Let's try again 2. Let's try again 3. You're saying it is changing. Let's try again 1. Let's try again 1. So it can generate either 1, 2 and 3 randomly. That's what it is doing. Now going back to our code and our project, computer's choice is going to be either rock, paper or scissor, one of this. That means I can actually do one thing is like I will randomly generate a number between 1 to 3 because here we are dealing with 3 objects, 1, 2, 3 objects. So we'll be randomly generating a number between 1 to 3. And if that random number is 1, we will say computer's choice is rock. If the random number is 2, the computer choice is paper. If the random number is 3, the computer choice is scissor. That's what we'll do. So for that purpose, let's do a random number. Const random number equals to same thing, math dot floor math dot random is a method into 3 and then finally plus 1. Okay, so this is my random number. Now after getting this random number, what I have to check, if the random number is 1, then the computer choice is rock. So you can use what, either if else or switch case, any of the thing that we can use. Let me use a if else. What I want you to do is, like when you are also doing this particular project by yourself, instead of if else, you change this to switch case. That's your task. Okay, so let me do like, if random number is 1, then my computer choice is rock. So I'll assume computer has selected rock. Else, if I'll now copy paste from here, I don't want to write it again and again the same thing. I'll paste it over here. I'll change it to 2. I'll say paper, and then the last one. So I don't need another if, the else is enough, and I'll say computer choices, in this case scissors. Did you notice why I had declared this computer choice with let and why I had declared this random number with const? Because the computer choice variable, once I have declared, I had assigned different kind of values depending on different kind of circumstances. But once the random number was created, the random number variable was never assigned any value after that. So it is one assigned and it is having that value constantly. That's the reason it is const. This is the reason this one is a let. Okay, now tell me, would you use const over here instead of let for the user choice? Think about it. Okay, now after this, I have the user choice from here and I have the computer choice from here. So let's do one thing. Let's do a console.log of showing that user selected comma user choice, and let's give another console.log computer selected computer choice. Now let us test if so far things works or not. So this is what I want to tell you guys, is like, whenever you're building a project, don't try to wait till the end to test your final outcome. Whenever you are making any logical change, immediately test it out whether so far the program is running as expected. So let us go to the browser, and here I am seeing getting started with rock paper and scissors game, and let me give rock. So I see user selected rock, excellent, computer selected paper. So you see that whatever I've given, that I am able to print, and from our computer it selected something very random and it is printing over here. Now our logic will come into picture based on this particular use case. If rock can beat scissor, then rock win. Paper can wrap rock, so paper wins. Scissor can cut paper, so scissor wins. Right? So let's determine the winner. We can do like, if, how do we do? If user choice is rock, if user selected rock, and if computer selected a scissor. If user selected rock and computer selected scissor, who wins? Rock and scissor. Rock can break the scissor, so user win. So what are the conditions that a user can win? One condition, when user selected rock and computer selected scissor. Another is when user selected paper and computer selected rock, because paper can wrap the rock. And once user selected scissor and computer selected paper, because scissor can cut the paper. Correct na? So along with this particular condition, there are two more conditions where user can win. So let us write all those conditions together, but this first condition should be or with other condition, isn't it? Because there are three conditions. So first condition, let us break it into different brackets so that we understand clearly. And now copy this particular condition, give a or, and then put second condition, give a or, then put third condition. So what is the second condition going to be? First condition, definitely if user says rock and computer says scissor, user win. What are the other circumstances that a user can win? Of course, if user selected paper and computer selected rock, so then also user can win. Then third is, if user selected a scissor and then computer selected a paper, then definitely user wins. So in all these conditions, we can say console.log of the user win. Yay. Okay. Else, if another case can come, user selected rock and computer selected rock. User selected paper, computer selected paper. User selected scissors computer selector seizures. That means if user choice and computer choice matches, in that case nobody wins. That means the game is a tie. So we have to take care of that case also. So we'll say user choice, if it is equals to computer choice, so in this case game is excellent. So two conditions we have taken care. Now the last condition would be like when computer will win. What is the condition for that? Let's do again. So the condition is if computer has to win, then only case the computer can win is if user select a rock but computer select a paper. Correct? In that case, computer can win. It's just opposite of it. If user selected a paper and the computer selected a Caesar, then also computer wins. If user selected a Caesar and computer select a rock, then also computer wins. So let us do one thing. Let us just copy paste this thing. Copy paste is not at all bad if you know what you are copy and pasting. Okay. Now let us just change this value. If user select rock, in that case, if the computer select paper, so in that case, computer wins, right? Because paper can wrap the rock. If user select paper and computer select scissors, and scissors can cut paper, so then again computer wins. If user selected scissors and computer select rock, so in that case again computer wins. And if none of these cases are matching, then we can have a final else. And in this case, we can say console dot. So this case is not matching where user is user own. This case is not matching where user and computer given the same input. This case is also not matching where computer can win. That means this particular case is such a case where we didn't, as a program, didn't understand what exactly user has given an input. So why we are not able to determine. So we can tell like, please check the input. We did not understand it. Correct? I think that's it. That's how our game is. So let us test it out. We have taken user's choice, we have taken computer's choice, we are matching it for the user to win, we are matching it for the tie to happen, we are matching it for the computer to win. And if nothing is happening, then we are suspecting that user's input is not correct. So we are saying that please check it out and give us the correct input. So let us go ahead and test it. So first thing, I'll give rock. So user selected rock, computer selected paper. Now user selected rock, computer selected paper. Paper can wrap the rock as per our logic. So computer wins. Very sad. Let's play again. Let's refresh this. This time I'll select paper. User selected paper, computer selected paper. Oh ho, game is a tie. Okay, I'll play again. This time again I'll select paper. See, user selected paper, computer selected Caesar. Again computer win. I'm still not able to win it. Let me select Caesar. So I'll refresh again and this time I'll select Caesar. Yeah, user selected Caesar, computer selected paper. Caesar can cut the paper and here user win. Finally I won. Great, na? So this particular game we have developed, this particular project we have developed, I hope that you understood it. I asked you a question. Can this be a const as well? Yes, it can be, right? Because is this user choice once we get, we are not assigning it anywhere. We are just using it. We are just using its value. We are not reassigning. So the thumb rule is wherever you can, you declare the variable with const. But if you have to reassign the value to that variable, then only you go for let and don't use var ever. That's the policy of const, let, and var. So you're done with this one. But there is one more thing that we want to do. I have refreshed every time to play the game again and again. But instead of doing that, I can now add some more code to it and then make it in such a way that once a game is over, I get a prompt back again asking, hey, do you want to play again? If I say, yeah, I want to play again, in that case, it allows me to play again. If I say, no, I don't want to play, it just exits the game. How do you do that? We know how to take the user input using the prompt, right? So let us create another variable called play again prompt. And then I'll use the same prompt. And here I'll be adding, do you want to play again? And I'll tell that give yes or no. That's it. Now in this stage, I'll I'll get the prompt. And then the prompt comes with two buttons. If you have noticed, there is a cancel button also. A user without putting anything can hit on the cancel button. Now on prompt, if user hit on the cancel button, prompt returns a null, which we have not handled in the case above where we have handled one prompt. Correct? We have not handled what happened if user click the cancel button, because this is going to be null. And if this is going to be null, it will have a null dot to lowercase. We have to handle such error. Let me show you in this case now, like how am I going to handle that error. So we'll do const, let's take play again. And here I'll be checking whether this has a value, any value. If that is having any value, I'll take this value and make it to lowercase, just like before. In other case, this play again prompt means it is either undefined or null. In that particular case, I will always assume the value as no. So this is how you do error handling with a fallback mechanism. If someone on that prompt had clicked on cancel, this guy will be null. If this is null, instead of showing it as null, I'm now handling it as a fallback value of no. Now here, then after that, it can have either a value, some value, or it can have no as a value. Now here I will check if play again is yes, means user have entered yes. In this case, I want to play again. To play again, what am I going to do? I will be starting this game again. So I'll be calling this function once more. I'm calling this function. Inside this function, I'm trying to do some kind of recursion, but with the base condition or the exit criteria. Only in this case, I'll be calling the function back. Otherwise, I won't be calling. Are you seeing like how we have learned the thing and we are making them into use? In other case, we can just say a console.log saying that thanks for playing. See you next time. That's it. So now, after some winner is announced, it will also give me a prompt to whether I want to play again or not. If I want to play again, I'm calling the same method. So again, the same game is going, else I'm just exiting it out. Excellent. So let's go ahead and start seeing this. All right. So let's start with, I'll give rock. Oh, see, user selected rock, computer selected Caesar. I win. And see, again, do you want to play again? It's asking for yes and no. That's what we have added, right? I'll say yes. So again, it is giving me the prompt. Now, rock, paper, scissors. Okay, this time paper. Oh, this time user selected paper, computer selected rock. Yeah, I won again. Do you want to play again? And nah, no. Over. Thanks for playing. See you next time. So the entire program is now working really, really well. I hope you understood, you enjoyed. And if so, please let me know in the comment section that you have enjoyed doing this, you have learned something from this one. And don't just watch it, please code it. Okay, I have given you a simple task over here to change this one to switch case. Please do that and then submit your task. Now we are going to go to another project, another simple project, quite similar project. So that's the reason in that project I'm not going to write each line of the code again and again, because most of the thing we are going to use from this particular project, but it's another project so that it will be practiced one more time for you. Let's get started with that one. Time for the next project. But the twist in the story is this project, I'm not going to do it. This is the project that you are going to do it, but I am going to do the mental model for it with you. And then you are going to do the code for it and you are going to submit this as a task for this particular session. All right. So let's understand what is this. This is a secret number guessing game. How does it work? You will ask user for a number between 1 to 10. So when you read this sentence, you clearly understand that you have to use again the random that we have seen in the last project. And you have to ask means you have to again give the prompt. So with prompt, you will be asking for a number between 1 to 10. Now, once user enter a number, you have to tell user the selection is too low from the actual number or too high from the actual number that they are guessing. Once you tell the user that if it is too low, what they will do, they will increase the number and again try to enter. If you say that it is like too high, they will reduce the number and again try to enter. And while doing that, user will finally find the right guess and then you will announce it, hey, you have found the right guess. Along with it, you are also going to tell the user, this is a very good thing, is like in how many attempts they have found this particular number. I have coded this particular thing and I have also given you as part of the code repository. You will find it for the day 7, but don't look into this, guys, please. First, try to build it by yourself. Let me show you the final output that I'm expecting. And then you can actually start coding it. And I'm also going to hint you like what are the things that you need to build for this. Okay. So first see the outcome. Here now, one more link has come. Guess the secret number game. I'm clicking on it. And the moment I click on it, you see over here, welcome to the number guessing game. Try to guess a number between 1 to 10. Let me guess the number is 5 and say okay. It's saying the number is too high. Try again. Okay, 5 is too high means now I'll be selecting lower than this. Let's say 3. Okay, too high. That means it is more or less than that. 1. Yes, congrats. You guessed the number in 3 attempts. So first attempt I have selected something, it said too high. Then again it was too high. Then again is saying that okay, this is the time I have selected correctly. But it also saying that in how many attempts I have selected. Great. Do you want to play again? Just like last time, I have showed it like how to do it. Yeah, let's play once more. Again, put a guess. I'll say 10. Oh, it's too high. 5. Oh, it is too high. 1. It is too low. So it's between 1 and 5 now. 3. Yes, the right number is 3. And I have guessed it in 4 attempts. So this is the game. This is the thing that you have to build. This is the logic that you have to build. Now let's understand how can you go about building this logic. Some hints for you. Though I am providing the hints, it doesn't matter that you have to go by this hint. You can actually go with completely your own logic and listening to your mind. Okay. So I have to give user a range between 1 to 10. So I have to do a max number and I have to do a mean number, right? These two I need. Then my secret number is a random number between the mean and max. I have already explained that if you know the maximum threshold, how can you get a random number between the mean and max? Pretty easy, correct? Then get the prompt from the user as a guess, correct? Create a variable to store the number of attempts. Okay, write the logic to check if the guess and the secret number are same. If not, continue a loop to ask again. So here we have to use loop. Now inside the loop, check if the guess is less than the secret or greater than. Accordingly, tell if the guess is low or high. Give the option to play again, right? These are the things that you are going to do. So your task is you are going to build the entire logic for this particular game and going to fill up this function, going to test it out and make sure that all the conditions are satisfied. That is provided over here. The previous project, rock, paper, scissors, is going to help you out a lot to generate the random number, the play again part, any kind of logical conditioning. It is almost the same thing. But again, if you are stuck, the code for the project is already there. You can go ahead and check like how this is done. But I'll always tell you, please, please, please try yourself first as many number of times you can. If you fail, if you get stuck, take a break, come back, try. Maybe after 3, 4, 5 attempts, then only take a clue and the hint from the code that I have given, and then see like where you were stuck and move on to the next stage. That's how it is. That's the end of it. So we are going to start with the module 2 next, and the first one of the module 2 is going to be about the hoisting and scope, one of the most fundamental aspect of JavaScript. And not only that, any library, any framework JavaScript based you are going to use tomorrow, you need the concept of scoping. So scope and hoisting coming next. We're getting into a little bit of advanced thing, followed by execution context. This and all this thing are going to come, all together. Stay well, guys. Keep learning, and don't forget to complete the task. Don't forget to like and comment on this video. Don't forget to share about 40 days of JavaScript, and please subscribe. Thank you very much. Take care.